The purpose of this video is to provide instruction for the proper receiving, handling, storage, installation, operation, and maintenance of Westinghouse VacCLAD W metal clad switchgear. This video is not intended to be a substitute for the printed instruction books provided for your assemblies. It should be used as an enhancement to them. Instruction books 32-255 and 32-255-1 are the publications for VacCLAD W switchgear. Westinghouse VacCLAD W switchgear utilizes the type VCPW circuit breaker. We at Westinghouse Greenwood take every step necessary in the packaging and shipping of our product to assure you of its delivery in first-class condition. When the carrier arrives at your door, it is most important that you follow certain handling and installation procedures. The switchgear is shipped as completely assembled as possible. Depending on the number of switchgear vertical sections, it may be necessary to ship the switchgear in several groups to facilitate handling. The breakers are shipped in individual containers. Each switchgear group and all the cartons and crates are labeled with a shop order number and a shipping weight. In the cardboard accessory box, there will be a shipping packet containing the shipping lists, storage, and handling drawings. When the switchgear arrives at the installation site, check it to make sure all parts described on the shipping list have been received. Do this before discarding the packing material. The preferred method of moving metal-clad switchgear is by overhead crane. Lifting members are bolted to the top of each shipping group for this purpose. Once the shipping group is located at its final installation position, the lifting members may be unbolted and discarded. If a crane is not available, the equipment is designed with the provision for attaching jacking plates in order to raise the units for the positioning of rollers under the shipping group. First, unbolt and remove rear covers. Remove the snap plugs. Attach the jacking plate. Raise the front and rear. And insert the pipe rollers. Never maneuver the switchgear directly on rollers. Always use the skids to protect the switchgear from being distorted or damaged. The shipping skids are held in place with bolts. Remove the bolts and discard the skids. If the switchgear is to be installed immediately, the following steps on proper storage techniques may be omitted. Packaging for shipping is not suitable for storage. A suitable storage place should be prepared. The switchgear should be stored indoors in a heated building that is clean and dry. The floor should be smooth and level and well drained to prevent standing water. The switchgear should be stored on skids to keep it off the floor and to allow for the free movement of air underneath it. In many cases, heat may be required to prevent condensation. When in doubt, heat is recommended. Please take time to review the steps outlined in Westinghouse drawing 700B-14, which is part of the shipping packet, to assure that you have taken the proper steps to adequately provide protection for your stored equipment. Before proceeding with the installation of this equipment, it is important that you are familiar with and clearly understand the following recommended safety practices. Before attempting to do any maintenance, always be sure to de-energize both the primary and secondary circuits. Never leave a breaker in an intermediate position in its compartment. Always crank the breaker into the fully connected or withdrawn position. Before removing a bolted-on cover, first make sure that all the circuits have been de-energized. Never try to disconnect or open the secondary circuit of a current transformer that is carrying load. In this situation, the transformer develops a dangerously high voltage. Before attempting work, either de-energize the circuit by opening the breaker or short-circuit the secondary of the current transformer. It is important to locate the switchgear so there is adequate space at the front, sides, and rear of the equipment. The recommended foundation consists of steel channels embedded in a level concrete floor. Keep the shipping skids on each group until it has been moved to its final installation position. The skids help protect the base of the switchgear and reduce the risk that it will be damaged or distorted during the move. When installing multiple shipping groups, start with the middle group and work outward. Move each group into position, lining up the bolt holes in the base of the vertical sections with the bolt holes of the steel channels in the foundation. Check the installation with a level across the width and length. If necessary, shims may be used to level the assembly. Remove the back cover from the vertical section at the shipping split. Remove the tie bolts from the cardboard detail box. Insert and tighten tie bolts in the rear upright members. Open the front panels on these vertical sections. Insert and tighten tie bolts between the front upright members. Bolt or weld the entire switchgear system to the channels in the foundation. Remove all shipping blocks or braces. Connect the ground bus tie links. These will be found packaged along with the switchgear accessories in the cardboard detail box. Next, connect the high voltage bus between shipping groups. This procedure is a bit more complicated. The horizontal and vertical metal barriers must be removed from the cable compartment as well as the main bus barrier. Other obstructions may also have to be dismantled. Splice plates, boots, and hardware are furnished to bridge the shipping brakes. These are already secured to the risers at each shipping split. Obtain the bus sections and black rubber snubbers to bridge the split. These will be found packaged with the switchgear accessories in the cardboard detail box. The plated surfaces of the bus should be cleaned if necessary. Slide the section of bus through the supports in the side of the vertical section. Slide the rubber snubber along the bus until it fits inside the opening in the bus support. Tighten the bolts in the splice plates to the torque values shown in Table 2 of the switchgear instruction book. Replace the metal barriers and any other parts that may have been removed to give access to the bus compartments. Connect the wiring which was disconnected at the factory for shipping. The wiring is labeled. Connect the main power cables. For a too-high breaker arrangement, metal isolation troughs are provided. These should be dismantled to facilitate pulling cable. Before connecting a cable, determine its phase. If two systems are to be paralleled, be sure the phase rotation and phase angle are the same to prevent damaging equipment. The rotation must conform to the shop order drawings so that instruments, relays, and meters will operate properly. Follow the instructions of the cable manufacturer to determine what minimum bending radii is permitted. Follow the instructions on insulating the joints so the insulation will taper properly through the correct gradient. The insulation will vary with the type and size of cable and with the service voltage for which it is designed. The troughs should be reassembled after cable installation is complete. Replace the rear covers on all the vertical sections. VCPW breaker elements are crated separately. Carefully remove the cardboard top. Remove the shipping bolts which secure the breaker to its pallet. Lift the breaker from the pallet. Examine all wiring circuits to make sure they have not been damaged or loosened during shipment or installation. Make sure all the remote connections are correct before the equipment is operated. Light out connections between the switchgear and remote apparatus, such as instrument transformers, auxiliary switches, and remote control and interlock circuits. The testing equipment will depend on the size and type of installation. Use portable voltmeters. Rig up some simple device for ringing or lighting out circuits. Coordinate the settings of the relays with the apparatus and other protective devices on the system. If the covers are removed from meters, relays, or other devices for installation or test, handle them carefully. Replace the covers as soon as possible to keep out dust and dirt. Perform a load check of the control circuits. Before energizing the control circuits, check the control bus with an ohm meter to make sure there are no short circuits in the control wiring. If an ohm meter is not available, connect a small fuse in series with the source of the control power. This will protect the control wiring against damage. The fuse should be 1/4 the normal rating of the circuit. Before installing the circuit breakers, take a moment to examine some of the features and details of this equipment. The breaker pan is the assembly on which the breaker sits while in the compartment. It houses various items which should be checked before inserting the circuit breaker. The ground bus extension keeps the breaker grounded while in the cubicle. The secondary disconnect provides control power to the circuit breaker. It automatically connects and disconnects as the breaker is inserted and removed. The racking screw and moving block permit breaker insertion and withdrawal. The levering cage assembly prevents levering a closed breaker. It may also be used to padlock a breaker in any position. Removing the pan cover exposes the optional MOC and TOC switches. The MOC switch is operated when the breaker is opened and closed. A plunger on the breaker pushes an operator on the pan assembly, which operates the switch through a linkage. The TOC switch changes state as the breaker is moved to and from the connected position. Its operator contacts the frame of the breaker as it is racked in and out. The code plates prevent inserting a breaker of a lower rating into the compartment. An optional provision allows multiple padlocking of the breaker racking mechanism. The rails on which the circuit breaker roll are also part of the breaker pan assembly. Metal safety shutters automatically operate to restrict access to the breaker primary disconnects. A maintenance tool is provided to allow an operator to manually open the shutters for maintenance or inspection purposes. To prevent accidents or injury, these shutters should never be permanently blocked open. Now the breakers can be installed. The VCPW breakers utilize external rails for insertion and withdrawal. One right-hand and one left-hand extension rail is provided as separate accessories. The rails are inserted on both sides of the compartment at a slight incline by sliding them into the associated slots. Be sure they snap into the horizontal position before lowering the breaker onto the rails. A breaker lifting yoke is provided with each shipment. This assembly snaps on the top of a breaker to provide a means for attaching an overhead lifting device. Any device which can support the breaker weight and lift high enough to reach the extension rails may be used, such as an overhead crane or hoist or a forklift. In other instances, a portable lifter can be provided. This device should not be used to transport the breaker, merely lift it into position. The VCPW breaker can be rolled directly on the floor. Examine each breaker for loose or obviously damaged parts. Before attempting to put the breaker in service, it should be carefully examined and operated manually and electrically. To perform the manual operations, place the maintenance tool in the emergency charge opening and charge the closing spring with up and down strokes of the handle. When charging is complete, the closing crank goes over center and the spring's charged-discharged indicator shows charged. Discontinue charging and remove the maintenance tool as soon as the charged flag is fully visible. Continued attempt to further charge may result in mechanism damage. Close and trip the breaker several times. Using a dry, lint-free cloth or a paper towel, clean all the insulating surfaces of the pole units. Conduct a vacuum interrupter integrity check as described in Maintenance Section 6 of the breaker instruction book. Also, check the breaker's primary and secondary insulation per Section 6. Contact erosion can be checked by viewing the moving stem of the vacuum interrupter from the rear of the breaker. Manually charge the mechanism and close the breaker. With the breaker closed, visible presence of the erosion indicator will assure adequate contact surface. Check the primary circuit resistance as described in Maintenance Section 6. The resistance should not exceed the value specified. Record the values obtained for future reference. Compare the breaker nameplate information with the switchgear drawings for compatibility. Breaker and compartment code plates match power ratings. They do not match control voltages. After going through the preceding steps, the breaker is ready to be operated electrically. It is preferred that this check be made with the breaker in the test position in the breaker compartment. While checks are performed in the breaker compartment, care must be exercised to make certain that the primary circuit is not energized. Make certain the levering nut is all the way up front. Push the breaker into the compartment test position as confirmed by a crisp metallic sound of the breaker levering latch engaging the levering nut. Remove the extension rails. Pull the secondary disconnect cage forward as far as possible to engage with the breaker secondaries. As soon as control power is available, the motor will start charging the closing springs. Close and trip the breaker several times to verify crisp closing and tripping operations. This check may also be performed with the breaker on the transport using the optional test cabinet, or on the extension rails using the test jumper provided. Always use the rail clamps when operating the breaker on the extension rails. These breakers are designed with safety in mind. The following procedures will verify the correct operation of the various safety interlocks provided for these breakers. Make certain the primary circuit is not energized during these tests. Close the breaker in the test position. The maintenance interlock may be checked by attempting to move the closed and charged breaker from the test to the withdrawn positions. The breaker will trip, close, and trip again to discharge the stored energy mechanism. Return the breaker to the test position and close it. The levering interlock will trip a closed breaker when an attempt is made to move it to the connected position. Using the levering crank provided, rack the breaker into the connected position. Please note, do not use any tool to lever the breaker from the test to connected position other than the levering crank provided. Correct operation of some of the interlocks is dependent upon use of the levering crank provided with the switchgear. The connected position is indicated by the red flag below the levering nut. Close the circuit breaker. The positive interlock will prevent levering a closed breaker. Now, trip the breaker and withdraw it 6 or 7 turns. The position withdrawal interlock prevents the breaker from being withdrawn by pulling unless it is in test position. The negative interlock will prevent closing the breaker unless it is fully connected or withdrawn. Now, hold the breaker control switch in the closed position. The position closing interlock prevents the breaker from closing automatically when moved to the connected position. Now, trip the breaker and move it to the test position. The extension rail interlock prevents the breaker from being withdrawn out of the enclosure unless the extension rails are engaged to the fixed rails. If the breaker functions correctly, it is ready to be put into service. Study and be sure to understand the diagrams furnished with each switchgear system. The details of the breaker control schemes vary from one installation to another. For example, common to most switchgear installations, a green light on the hinged instrument panel on the front of the breaker compartment indicates the breaker is open. A red light indicates the breaker is closed. In a DC control scheme, the red light supervises the trip coil and indicates the trip coil circuit has continuity. These diagrams comply with the requirements set forth by IEEE, NEMA, and ANSI. All of the schemes are designed to coordinate electrically with the mechanical design of the breaker. When inspecting, repairing, and performing maintenance on metal-clad switchgear, the fact that dangerous voltages may exist must be kept in mind, and precautions must be taken to ensure that personnel do not come in contact with energized high-voltage parts. Failure to do so could result in personal injury or property damage. Some common general precautions for high voltage work are: all connections should be considered energized until the crew expecting to work on them is assured that the circuits are de-energized, and every possible precaution has been taken to see that there is no chance of a circuit being energized while the crew is working. Switches or breakers which have been opened to de-energize a circuit to permit work on equipment should be locked or blocked open, and a suitable visible warning device placed on them. Do not work on parts normally carrying current at high voltage until these parts have been disconnected and grounded to the ground bus. Provision should be made by maintenance workers for connecting adequate flexible ground leads to every part of the switching equipment. A good and reliable ground connection is necessary for every switchgear installation. It should be of sufficient capacity to take care of any abnormal condition that might occur on the system, and should be independent of the grounds used for any other apparatus. Metal-clad switchgear is designed so that internal compartments provide metal isolation between the circuit breaker compartment, the main bus, and the primary line terminations. Access to high voltage parts is provided by removable covers and barriers, which should not be removed unless the parts to be exposed are de-energized. In VacCLAD W switchgear, both the stationary main disconnecting contacts and the ring-type current transformers are located behind the glass polyester CT barrier. Since the upper and lower contacts and transformers are easily exposed, caution must be exercised. Do not expose any contacts or transformers unless all upper and lower high voltage parts are de-energized. Failure to do so could cause personal injury or property damage. This switchgear can be provided with drawer-mounted voltage and control power transformers. They are connected and disconnected via extension rails identical to those provided for the circuit breakers. A built-in interlock provided on a controlled power transformer drawer requires the operator to trip the main secondary breaker before the drawer can be disconnected. Withdrawing the drawers automatically disconnects both the primary and secondary terminals. The primary fuses are also momentarily grounded to assure the operator the transformers are de-energized. In VacCLAD W switchgear, simply opening the drawer operates shutters which automatically cover the primary disconnects. Do not attempt to remove the back covers, the disconnecting assemblies, or shutters unless the high voltage circuit to the compartment is de-energized and precautions have been made to prevent re-energization. Failure to de-energize the circuit and take precautions to prevent re-energizing could result in bodily injury or electrocution. When energized, these circuits carry lethally high voltages. With the exception of apparatus such as current transformers and rear-mounted heaters, control equipment and wiring is generally accessible without exposing high voltage parts. Local conditions such as high humidity, salt-laden atmosphere, corrosive gases, heavy dust, or severe circuit operating conditions are considered to be abnormal and will require more frequent inspections. It should be emphasized that a series of brief inspections should be made at quarterly intervals until the progressive facts of the local conditions can be analyzed to determine a schedule which will maintain the equipment in satisfactory condition. The following general requirements should be helpful in setting up the program. Before attempting any inspection or maintenance, be sure that all primary and control circuits have been de-energized and grounded as required, and that proper steps have been taken to be sure that they will remain de-energized until all work is completed. Failure to do so could result in bodily injury or electrocution. When energized, these circuits carry lethally high voltages. The maintenance schedule for individual devices such as circuit breakers, relays, etc. should be based upon recommendations contained in the individual instruction book for the device. The switchgear installation should be given a thorough overall maintenance check at the end of the first year in service because it provides an opportunity to evaluate conditions at an early point in the life of the equipment. Where conditions are abnormal, more frequent inspection and maintenance is necessary. Where conditions warrant, a longer period of time between maintenance periods may be used. The following require attention. For maintenance of buses and connections, de-energize primary circuits and remove cover plates from the primary compartments. Before cleaning, take mega readings between phases and to ground. Inspect for signs of overheating or weakened insulation. Remove dust from buses, connections, supports, and enclosure surfaces. A vacuum cleaner with a long nozzle will be helpful. Wipe clean with a warm soap water solution. Wipe dry. After buses have been dusted and wiped clean, take mega readings again between the buses and ground and between phases. Keep a record of these readings for future reference in determining when trends occur that would indicate a lowering of insulation resistance. Periodic high potential tests are not required and are recommended only after repair of high voltage buses or installation, or when the trend of mega readings indicates it to be advisable. This field test should be made before the main cables are connected and should not exceed 14.25 kilovolts, 60 hertz, 1 minute for 4.76 kilovolt switchgear, and 27 kilovolts, 60 hertz, 1 minute for 8.25 kilovolt and 15.0 kilovolt switchgear. Transformer primary fuses should be removed and surge protective devices such as capacitors and arresters disconnected during high potential tests. For maintenance of disconnecting contacts and supports, remove each breaker from its compartment. De-energize primary circuits and expose primary contacts and their supports. Wipe clean with a cloth moistened in a non-flammable solvent. Inspect for abnormal wear or overheating. Discoloration of the surfaces is not harmful unless corrosion due to atmospheric conditions is severe, leaving deposits on the surface. If necessary, these can be removed by a light application of crocus cloth. Check each breaker while it is out of the housing for all items recommended in the breaker instruction book. Inspect all primary and secondary disconnecting contacts, such as those on draw-out transformers for abnormal wear, fatigue, or overheating. Replace if necessary. Otherwise, treat the same as the main disconnecting contact shown earlier. Relay contacts should be inspected and dressed or replaced when the surface becomes pitted. Unless repetitive duty has been experienced, little attention should be required. Instruments, relays, and other panel-mounted devices should be maintained according to the specific instructions supplied for each device. Check all secondary wiring connections for tightness, including those at the current and potential transformers and at the terminal blocks where circuits leave the switchgear. Make sure that all secondary wiring connections are properly connected to the switchgear ground bus where so indicated. Visually check and manually operate mechanical moving parts such as the shutter, the position interlock, hinged doors, and the draw-out features of the transformers and fuses. Examine mechanical mating parts such as the breaker secondary contact blocks, side rails, and trippers. Check all labyrinths, grill work, and air passages for obstructions and accumulations of dirt. Westinghouse switchgear is designed so that lubrication is not required under normal conditions. However, abnormal local conditions or severe circuit operating conditions may demand the use of lubricants. In such cases, a dry or powder lubricant should be used on moving or mating mechanical parts, and a thin film of Vaseline on disconnecting contacts. The application of the lubricants should be held to a minimum to reduce the accumulation of dust and dirt. When ordering renewal or spare parts, include as much information as possible. In many cases, the style number of the new part can be obtained from identification on the old part. Always include a description of the part. Specify the rating, housing number, and shop order number of the metal-clad housing in which the part is to be used. We hope this video has provided you with a valuable supplement to your instruction books. If the procedures and recommendations presented here are followed, you can be assured of many years of reliable service. We at Westinghouse in Greenwood, South Carolina, will continue to do our very best to provide you with top quality medium voltage switchgear for all your present and future needs. Because at Westinghouse, we're making sure.